Welcome to reverse osmosis. RO is a water treatment tool that is chosen when the water has significantly high TDS content or mineral content that will either cause significant scale or corrosion to food service equipment where other methods are not as cost-effective in meeting those requirements. And what we have here in these two pictures is a combi oven that is actually only several weeks old, and due to the wrong type of filtration being originally specified here, we have two issues going on. You can see here and here we have some brown and white scale forming on the inside of the unit. Problematic, but not an overwhelming issue to manage. But the real significant issue here is corrosion, which will show up on the welds and the racks of a combi oven first because they're not the same quality of steel as the rolled press steel is. And when dealing with large commercial kitchens with lots of applications or lots of steam cooking equipment, the really only cost-effective solution for treating this water is reverse osmosis. Now here is that same oven that then had an additional product put on it that wasn't specified correctly because no one had looked at the water chemistry. They'd even gone to the extent of taking a stainless steel hose clamp and trying to repair the rack holding system doing this. And notice, this stainless steel clamp rusted out very, very quickly as well. Well, why is this happening? This is due to corrosive elements in the water like chloride and sulfate, and they create acids when heated to temperature, and they react with steel, causing corrosion. And these are chemical species that are only really effectively removed by reverse osmosis in larger applications. They can be use tools like Claris Prime to manage these issues in very small, low water volume applications. But when it comes to steam cooking equipment, we probably are going to go with RO for a cost-effective solution. So how does reverse osmosis work? Well, we're going to use that technology when the ion content needs to be greatly reduced and managed to get within warranty specifications, and when we have ions that can only be removed by reverse osmosis. And those are chloride, sulfate, and nitrate. And then we're going to have the membrane selectivity. How efficient is this RO at removing TDS and mineral content? Well, most membranes are 90 to 99% efficient in removing TDS. So they're going to reject almost all mineral content. And how a reverse osmosis membrane works is you have essentially four features to it: the inlet, the outlet, and the permeate outlet, the product water we're making, and the membrane itself. The waste stream is restricted so that we put back pressure on the water coming in, and then the inlet water is pressurized. And this creates a force to push that water through that membrane. And the membrane really is just a strainer, very much like a colander is for pasta, that we're keeping the mineral content on this side of the membrane, or the pasta in this case, and straining out the water, which is purified of all that mineral content, which is sent to a tank to be delivered to the application. Now, the filtration range in which reverse osmosis resides is right at the small end of the spectrum to the left of the spectrum here, down in the metal ion and aqueous salt and atomic radius range. And this, to describe what things are down here: sodium chloride, table salt, lead, iron, calcium, and magnesium, all the stuff that causes us hardness issues is strained out at this level, leaving pretty much nothing but water. And up at this end is where we deal with our particulate filtration, the large rocks and twigs and stuff with half micron and larger filtration. So what applications can we use RO for? Well, RO with the MRS 600 high efficiency systems with their blending capabilities have application to a great many situations. They can be used as point of entry systems with water softening as a pre-treatment for the RO and managing the water going to the hot side of the building, saving water and energy on water heating for the building. And then the RO can be paired with different tank combinations to deliver different flow rates and up to 2 different water qualities out of a single system, feeding an entire store, like in this case, a whole grocery store with delis and combi ovens and fresh food service concepts can be handled by a single system. Or it can be used as a point-of-use system for a high-volume, water volume-using combi oven or a whole coffee bar just for the coffee-using equipment in a higher-volume coffee store. Or it can be used as a single point of use in a small convenience store where it's handling the fountain beverage and ice in extreme situations. Now, the key elements of a reverse osmosis system, and this is for our MRS 350 and smaller units, and pretty much all RO systems sort of follow the same technology. The membranes used in food service applications, because they're most suitable to what we do, is a thin film composite membrane. And they will reject up to 90 to 99% of TDS, so we average it on around 95% TDS reduction, which is the mineral content of the water. And we have a recovery, which we make typically up to about 33% of the water is recovered and not gone to waste. So that means 67% of the water we're bringing into this type of system is going to go down the drain with higher mineral content. And we use a carbon block or carbon filtration as pre-treatment for an RO membrane because thin film composite membranes are sensitive to chlorine and chloramine, which can cause them damage and burn through the material. So we remove the chlorine and chloramine from that system. And that water has to have typically a minimum inlet pressure of 60 psi in order to force that water through the membrane, come out that membrane with enough pressure to fill the tank and store water at a usable pressure for the application. Then this tank is charged with air, and that air pressure acts as a spring to squeeze that water back out when the application calls for water. And when that pressure drops enough in this tank, because as it fills, this tank is going to pressurize and put back pressure on this valve and shut it off when this pressure is equal to the incoming pressure. And when that happens, this valve closes. So when the tank delivers water and drops approximately 20 psi in pressure in the tank, this valve will open up, allowing water to go through the carbon filter and to be processed and made for storage again. Now, there are certain factors that impact the production of RO permeate water, the water we want to make. And the first one we want to talk about is applied pressure. As we increase the pressure on the membrane, the force pushing that water through, we're going to increase our productivity, which means we're going to produce more water per minute than a lower pressure. And our product quality is going to be increased because we're going to be forcing more material in contact with that membrane, creating tighter and tighter pores as the pressure stays elevated. But the exact opposite takes place when we have lower pressure being applied to that same membrane. You're going to see productivity drop because we don't have the same force to push that water through that very, very fine strainer of a membrane. And you're going to see product quality drop slightly because you no longer have that material being forced into the membrane, making those pores a little bit tighter. So your product quality is going to drop slightly. Now, feed temperature of the water coming into the RO membrane is very, very important to food service applications. There's a sweet spot in thin film composite membrane technology, and that's right around 77 degrees Fahrenheit. And as we know, as things warm up, they tend to expand. As things get cold, they tend to shrink. So what this impacts the membrane is that as we hit it with warmer water above 77 degrees, that membrane is going to expand, opening up those pores in that membrane, allowing more water to go through. So we're going to make more water, but that water is going to be of a higher TDS or lower quality than before because those pores have opened up and are going to act like bigger gateways and allow more mineral content through. Now, just the opposite is true when we start with colder water. For every 10 degrees below 77 degrees Fahrenheit, we lose 13% of productivity of that membrane. So that's very important in northern climates to take this into account in sizing your RO, or the need to add a tempering valve to make sure the water stays in that 77 degree range. Because as we drop that temperature, that membrane is going to shrink and tighten up. So we're not going to be able to get as much water through that membrane as quickly. So our productivity drops per minute. But since that membrane's tighter, we're going to reject more and more mineral content, so our product quality goes up, or we're going to have lower TDS water. But this is very important to northern climates because in the summer you may have an RO membrane that meets your application's needs at the 70, 75 degree water coming into it. But then when it's in the winter time and that water's down in the low 50s or mid to low 40s, you're going to lose up to almost 40% of productivity, which may now make that system no longer produce enough water for the applications. Another factor that impacts RO production is the feed water TDS. How much stuff is in the water that we need to remove? So as we drive that up, productivity is going to drop because we're going to have more stuff that's going to contact that membrane and tighten it up. But the other thing it's going to do is going to decrease product quality. If you remember, RO membranes reject water on a mineral content on a percentage basis. And let's just, for ease of math, say 90% reduction. So as we increase the TDS number from, we start off with 100 TDS water in one case and reduce that by 90%, you're only going to end up with 10 parts per million of TDS in the water. But if you raise that TDS up to 500 parts per million, and 90% reduction is going to leave you with 50 TDS water. It's just higher TDS based on what's coming in because it's a percent reduction. Now, the more we drop that TDS, the more productivity we're going to get out of the membrane because we're not plugging it up as quickly, and that product quality is going to go up based on that percentage model. Now, percent conversion or recovery, how much water we are going to recover depending upon how we set that waste stream. So the higher we drive the recovery, the more water we're going to make and keep. That's going to, when we restrict that waste flow, that's going to drive us to make more water. But as we push harder and harder on that membrane, product quality is going to drop because we're going to be concentrating that mineral content in that membrane higher, so we get slightly higher TDS out. But as we drop the waste restriction or lower the conversion or recovery, we're going to lower productivity because we're going to be letting more water go to waste. And our product quality is going to increase because we're not adding as much TDS or concentrating as much TDS inside that membrane. So there's a balance here between percent recovery and the rejection that allows us to optimize production quality from the membrane. And then there's product pressure or back pressure from the tank via the membrane. So as we increase back pressure as a tank is filling, we're going to reduce productivity because we're pushing back on that membrane. So the pressure across it is starting to equal out, so it's harder to move water through that membrane. Our product quality is going to drop because more TDS is going to have a chance to move through that membrane at lower pressure. But when we drop the back pressure on the RO membrane, our productivity is going to increase because we don't have that force pushing back as much. And that is going to increase product quality because we have that pressure differential across our membrane. Now, comparison of the MRS 600HE and HE2 systems. These two systems have both a pressurized pump and a pump to pressurize the tank. So it provides even pressure differential across the membrane. The MRS 600 has an onboard storage tank and has two outlets for two different kinds of water quality, pure RO for steam applications and a blended output for coffee applications. It requires external pre-carbon filtration to protect the membrane. Whereas the MRS 600 HE2 has two separate pumps, but it requires an external tank because there's no onboard tank included, but that tank sizing allows us to be flexible with the size of tanks to meet different applications. It has pre-filtration on board for protection of the membrane, and it has the ability to produce two water qualities depending on a plumbing configuration, and it also has the unique feature of a soft water inlet for RO water production, for optimal production there, and a hard water inlet for those applications that do not want sodium in their water, such as coffee and espresso and tea, where you're able to blend in some hard water to achieve optimal mineral blend for flavor profile for products. Now, key points of the MRS 600 series is most reverse osmosis systems are around 25%. This means that for every 1 gallon of good water, 4 gallons of water go down the drain. While the MRS 600 series is just opposite of that. For every 4 gallons of permeator good water we want to keep, we're only throwing 1 down the drain. And that's with the use of a water softener as pre-treatment. The other benefits is we have two pumps that keep the pressure differential across the membrane static and low, so it allows us to really move water across that membrane and maximize that efficiency. And also, good system design is important. Hard water directly into the system will decrease performance and shorten membrane life. And PRVs, pressure relief valves, are necessary on the tank installation to meet code. Now, reverse osmosis tanks, well, why do we need them? Well, reverse osmosis systems, because of the size of the material we're straining out and how tight the membranes are, make water slowly. The MRS 600 makes water at about 0.4 of a gallon a minute, or just under a half gallon per minute. The MRS 350 about a quart a minute, and the MRS 225 at about 0.15 GPM per minute, and that's at 77 degrees. So we have to factor in temperature here in as well when we size something. And so we're making water at this slow rate. Well, we want to be able to make that water and store it and deliver it. Why? Because in order to size an RO to meet a application's direct needs, it would require a very, very large, expensive RO. And the tank allows us to decrease not only the size of the system, but the expense of it as well, and store that water, that valuable water we've made. And the tank is typically in a bladder tank installation is going to have an air cell in it that we fill with pressurized air. And that provides the spring or the trampoline effect inside the bladder tank that pushes the water back out. So as the system fills this tank with water, it's going to surround this air vertical ladder, an air cell, and compress it with water pressure. And then that air acts as a spring, so when a combi oven asks for water, it pushes back and squeezes the water back out of the tank. And this cycle goes back and forth as the tank drains and fills. So when we size reverse osmosis systems in tanks, what are the key considerations? Well, what equipment is there, and how often is that equipment used?